If you stop maintaining the bridge, it will eventually be unsafe to drive across. And it seems just like a strange thing to say about, a digital good, that it will degrade. Like, goo-gle is not subject to wind and weather, but it is subject to constantly changing context. The goo-gle of 15 years ago or 20 years ago, which you can download, may or may not compile on your current machine.
Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Paul Ramsey. Paul is the co-founder of the PostGIS extension, so this is the spatial extension for the Postgres database. He's also been on the podcast a couple of times before. I'll put links to those episodes in the show notes. You can find them if you're interested. One episode was all about serving vector tiles directly from a Postgres database, and there was another episode about Spatial SQL. But today on the podcast, we're going to be talking about GDAL, so the Geographic Data Abstraction Library. We're going to talk about what it is, and later on in the episode, we're going to get into the business model behind it. Just before we get started, a big thank you to OSGeo, the Open Source Geospatial Foundation, for helping make this podcast episode possible. I really, really appreciate your support. Hey Paul, welcome back to the podcast. Thanks for showing up again. Really appreciate it. Today we're going to be talking about GDAL, but I think before we start doing that, perhaps you could just introduce yourself to the audience, just in case they haven't heard of you before.
Sure. My name is Paul. I'm an open source software developer, which means that I work on software which is free to download, free to use, and free to remix with other software. As an open source software developer, one of the things I have worked on in the past and continue to work on, hope to work on in the future, is GDAL.
Okay, what is GDAL? That's the first question. And maybe we could throw into the mix there, how do we pronounce it?
Yeah, that's a deeper question than you'd think. So GDAL, acronym GDAL, Geospatial Data Abstraction Library. And you will find me pronouncing it variably as GDAL or goo-gle. And actually, I find myself coming back to goo-gle frequently because it trips off the tongue a little more easily than GDAL. And it was the original pronunciation. If you asked the founder of the goo-gle project how he pronounced goo-gle, he would for many years say goo-gle. And then when he stopped being the maintainer of the project, he went and took a job with Google and found it very difficult to go saying that, I work at Google and I was the founder of the goo-gle project. It got very confusing. So yeah, either way, you'll probably hear me saying goo-gle a lot. Goo-gle is data plumbing. I was thinking of analogies this morning, like the idea of, you ever bought an international electrical plug set for like traveling, and it's got like 15 different shaped plugs.
Yeah.
Electricity is just electrons moving around, right? That's all it is, quote unquote, just electrons moving around. But there's lots of ways they can move around, right? They can move around as DC, they can move as AC, they can be 120 volts, can be 240 volts. And then of course, there's all these different ways you can plug and join together electrical things. So while at the core, it's just electrons vibrating, it can actually be quite complex to get your hairdryer spinning. In the same way, raster is just a bunch of pixels. Each pixel has a value. That's the core idea what a raster is. But there's hundreds of ways to arrange that data on disk, arrange it in files for computers to work with. And there's hundreds of ways to manipulate those pixels to work with it as a GIS professional.
Okay, so we were talking about GDAL, and you were saying, rightly of course, that it's the Geographic Data Abstraction Library. You just talked about pixels there. Two questions. So when we say library, what do we mean? And are we just talking about a tool that's only useful when we think about geospatial raster data?
Library is a software term of art. When programmers write some functionality that is likely to be usable in different programs, they extract it from the one program and put it into what's called a library. And then multiple programs can use that same library to take advantage of that functionality. So goo-gle is built primarily as a library, but also ships with a bunch of command line tools, which allow you as a user to directly use that library. But because it's a library, it also shows up in other places, which I guess we'll talk about later. Does it just do raster data, which is say like, imagery, things that can be formed in pixels? No. This idea of data abstraction comes out in other forms of GIS data. So the other most prominent form of GIS data is vector data. And there is a subsection of goo-gle called OGR, which is an even worse acronym than goo-gle, and people will variably pronounce it as OGR and ogre. It may stand for OpenGIS Simple Features Reference Implementation. It may not, but people say OGR, and that's used for very much the same things as goo-gle is used on the raster side, but for plugging together different vector formats and doing transforms on that data.
I think we should save the library side of things till later on. We talk about where else we can find the library in use today in the different programs, different software which makes use of it. But let's say we went to gdal.org/download, and we downloaded whatever it is that we get there. Yeah, what would be in the box when we open it up?
Most of that, there's a number of things on that page. Most of the links on that page are to source code. And that's because the expectation is that goo-gle is going to end up being consumed by end users indirectly. They are either going to download a third-party build that someone has made for their platform of choice, like the Windows build link is to a Conda Windows distribution, or they'll be getting it through some sort of an operating system package manager. Like if they're on Mac OS, the easiest way to get goo-gle is to use Homebrew or Mac ports. If you're on Linux, the easiest way to get it is to pull it down from your Linux package manager, not to pull the source code and build it directly. So if you do get it by pulling down the Windows build or getting the OS 10 build, Mac OS build, or Linux build, what you'll get is a library, which you won't use directly because it's just there to link to software, and you'll get a big pile of command line tools. And those tools, the ones you're most likely to use are goo-gle Translate, which is a program for the format translation problem, and goo-gle Warp, which is a tool for raster coordinate reprojection. And then there's a lot of other tools. Like there's a contouring tool that'll take DEMs and generate contours. There's slope and aspect calculators, but probably 95% of the goo-gle use that people use in their day-to-day and the people use in the cloud is that translating formats function and that warping, reprojection, resampling function.
And just to be clear, this is a standalone package. So if I download this box of executables, it's just going to work. Is that correct?
Yep, that's right. Yep, the little command line tools, they just do what they do. But that's not necessarily the only way you can use it. But that's what comes in the standard goo-gle download box.
We mentioned it before, OGR. I think there's a real famous OGR executable. Would you mind naming that for us?
Yeah, that's OGR2, numeral 2, OGR. The implication being OGR is a pile of formats, so you can go from any OGR format to any other OGR format. So go from shape to file GR database, or go from Oracle to PostGIS, or go from GeoJSON to CSV, or any other combination of those things. OGR2 RGR lets you go from any OGR format to any OGR format. goo-gle Translate is the same thing for raster formats, but doesn't have that cool numeral 2 form to it.
Yeah, that was definitely a mistake. Do you have any idea of how many formats we can translate between when we think about raster?
Yeah, I went to the formats page, goo-gle.org formats page, and got out my mouse and counted down. There's over 160 in the raster domain. And if you're a GIS professional, you've probably heard of JPEG 2000 or Mr. SID or GeoTiff, maybe USGS DEM as formats. If you're a cloud developer doing something cloud, you've probably heard of COGS, the cloud optimized GeoTiff format. If you're working in data science or in environmental science, you may have used HDF5 or NetCDF. Those would be ones you might have heard of. You may or may not have heard of GRIB. GRIB is used for some obscure weather data. If you're as old or maybe older than me, you might remember NITF or SDTS, which are old USGS and US government formats, which are largely defunct now. But it's a lot. It's a lot of functions, ones that date back to the dawn of GIS formats and things which are brand new.
I can't tell you how many times this little package of tools has absolutely saved my life, saved me hours and hours and hours of incredibly frustrating work. Just to be able to open up the box, pull out OGR to OGR and transform between whatever vector format I have to whatever I need, it has been unbelievably time-saving for me. Earlier in the conversation, we talked about the library side of it. So we've talked a little bit about these executables that we can download and just use the way they are. Could you talk us through the library and what the implications are? How can we get to this library from other programming languages?
Yeah, so goo-gle's written in C++, ships with a C API, and those are like small implementation deals. But the existence of a C API means that it's bindable to a large number of languages. It turns out that having a C API is sort of like the lowest common denominator lingua franca to get your functionality into almost any language. So there are easy scripting language bindings available to goo-gle from Python, from R, from Ruby, from Perl, which I'll call directly into the C API. Because it's C, obviously you can call goo-gle from C or C++. Also other compiled languages, the new ones like Rust or Go, we're very happy to call into C. So you can build your Rust program, your Go program, and call into goo-gle no problem. Because there's a C or C++ binding. The virtual machine languages like .NET, Java, Node.js also have bindings. It really is a lingua franca. And because it's a library, you can use it with these other languages. But B, you can embed it in much larger things that don't look like scripting tools or tiny command line tools anymore. So in the wild, you will find it in QGIS. No big surprise there. Open source desktop GIS uses the open source format translation library. So when you do things like import raster into QGIS, that import is coming in via the goo-gle library abstraction. When you publish rasters from GeoServer using non-standard formats, that'll be pulling it through goo-gle. When you look at rasters in Google Earth, inside Google Earth, you'll find, lo and behold, there is the goo-gle library. Same thing in ArcGIS, same thing in the FME feature manipulation engine. The raster reader for FME is based on goo-gle. So really almost all like the add raster options in GIS programs end up being backed by goo-gle. And it's not entirely surprising, right? The value proposition of being able to add support for one library, just do the programming, add one library, goo-gle, and boom, you immediately have support for 160 formats, right? If you're writing a piece of software, it's like, this is a huge value proposition. And the alternatives look terrible, right? Are you going to just do an in-house implementation of every format a customer requests? Basically, the largest GIS company in the world, which is Esri, that did that value proposition calculation, decided it just made more sense to tie into goo-gle than to write their own internal format translators for every format. So if the largest companies decided that value proposition makes sense and they have access to truckloads of programmers, it equally makes no sense for any smaller company to write their own formats. So the very existence of goo-gle now is like a black hole that sucks everybody into it, because it doesn't make sense to do a single end-to-end point format conversion, when if you just make the end be goo-gle, you get a 160 point format converter. It's a no-brainer.
I think it's really interesting on the website there. One of the frequently asked questions is there a user interface to this? And then they point at all of these different programs, and there's literally hundreds of different programs which make use of this open source translation machine somewhere in their engine room. It's absolutely incredible. In a previous conversation, we talked a little bit about the relationship between cloud computing and open source software like GDAL. Would you mind just sort of walking myself and the listeners through that, please?
Sure. So cloud computing is a setup where a single large company puts thousands and thousands of servers on racks in wonderful data centers and then rents access to those servers. And increasingly rents access not just to those servers, but to pieces of software that run on those servers. And that economically only makes sense because there is no software cost as these cloud companies expand. So when you go and spin up a server in AWS or in Google Cloud, it is 100% of the time a server which is running the open source Linux operating system. And why? Because it would cost way too much to license proprietary operating systems for all these thousands and thousands and thousands of servers that they're running. The same thing is true for what's happening in the world of raster imagery collection and processing. One of the big step changes in our industry over the last 10 years has been that we've gone from having, a few dozen sensors flying around the world in orbits to having hundreds and hundreds of sensors flying around the world in orbits and dumping back data continuously. We've gone from having a few aerial photography companies to having people flying aerial drones constantly. There's this incredibly large stream of raster imagery data which is rolling into the world, and it's rolling into these cloud data centers. So if you go and look for the results of the Landsat 8 mission, you will find that they're no longer stored on government servers at the EROS data center. They're stored on the AWS cloud, and they're rolled up there more or less in real time as they show up on the downlink. They get processed and pushed up to pushed up to AWS. And there's two aspects to that processing. One, the processing is, before it's pushed up to AWS, is largely done by goo-gle. And secondly, once that data is up there in AWS, the access to that raw data is largely done via goo-gle, because the data is being stuffed up on these clouds in what's called the cloud optimized GeoTiff format. And that cloud optimized format is one which goo-gle very happily reads. So it's possible to spin up a computing server on AWS, point it at the cloud buckets that AWS is maintaining of these huge corpuses of data, run the processing to pull out the information you need, reproject it, do processing on the pixels, pull it down to your system. And all that work is being done with goo-gle. And it only makes sense, again, because the piece that you're using to do it is open source and freely available. So you can afford to run 1,000 copies of goo-gle to process all that imagery. This is what Planet Labs does. I mean, Planet is sort of the poster child of having an unimaginably huge image fire hose, because they have hundreds of these little Dove satellites up spinning around. They're collecting imagery for the entire globe every day. And the data actually never leaves the cloud. It arrives in the cloud as soon as it comes off the sensor and off the downlink. The Planet does not have any servers in its home closets. It exclusively uses the cloud, and each step of the processing, from raw image off the sensor to orthorectified to corrected to color balanced and mosaic, each step is going through that goo-gle API in different ways. Some of it using built-in functionality of goo-gle, some of it using functionality that Planet has written themselves and is pushing through the goo-gle Access API so they can touch the formats, but all of it going through that API. And yeah, it only makes sense. They can only spin 1,000 copies of goo-gle because it's free and open source.
Okay, so we've got this free and open source piece of, I guess, what we could describe as critical geospatial infrastructure. Do you think that's a fair statement?
Oh, it's 100% fair. If you took away goo-gle right now, not only would Planet stop running and Landsat would stop moving to up to the cloud, but I don't know, Mapbox would no longer be able to run all their processing to produce their imagery mosaics. Google has the same processing chains for their image mosaics. They also use it to feed their Earth engine. Microsoft is using it extensively in their new planetary computer project. In the defense intel space, Maxar is pulling down data, and that data gets pushed through goo-gle as one of the processing pipelines. All the new tools which are looking at things like synthetic aperture radar, all these data sources are using this abstraction library. You take it away, everything stops. Because it's free and open source software, that's not actually something that could ever happen. But as is true of other critical infrastructure, if you don't keep it up, it does inevitably degrade. If you stop maintaining the bridge, it will eventually be unsafe to drive across. And it seems just like a strange thing to say about, a digital good, that it will degrade. Like, goo-gle is not subject to wind and weather, but it is subject to constantly changing context. The goo-gle of 15 years ago or 20 years ago, which you can download, may or may not compile on your current machine. It certainly will have a lot of bugs that have been uncovered in the last 20 years. It certainly will not run as fast as a modern version of goo-gle, which understands modern processors. All that, little extra effort is stuff which has happened over the years because of maintenance of the code base. So yeah, it's critical infrastructure. If it went away, the world would stop. It's not going to go away, but if we don't keep maintaining it as we maintain our other critical infrastructure, it will gradually degrade and quality will go down.
Okay, so we've said the word maintain quite a few times, and this makes perfect sense when we talk about critical pieces of infrastructure. We recognize their value, and therefore we take steps to make sure that they will continue to be able to provide that value into the future. So the next big question is, who is maintaining this piece of infrastructure? What team is working diligently through the night to make sure that we can continue to enjoy all the benefits of this?
The historic business model of goo-gle has been that there is one singular maintainer. I mentioned the original maintainer, the founder of goo-gle. That's a fellow named Frank Weimerdamm, who did it for at least 10 years, maybe 15, and then left for a different job working for Google. And he actually now works for Planet. He's one of the major users of goo-gle, and also continues to contribute to the project. And there has been a new singular maintainer since then, a fellow named Evan Ruo. And the way that business works, the way the single maintainer business works is that you make all your money by doing service contracts to people in the goo-gle community, companies, governments, usually in the form of adding a format, sometimes in the form of adding a feature. And you get paid for adding those formats and features. That's how you end up with 160 formats in the raster space and 80 formats in the vector space, and lots of cool features. But then they also do all the other work of the project. And by that, I mean things like fixing reported bugs, integrating third-party contributions. Someone comes in and says, hey, I have this new fix for you, or I've done this little tweak for you. So you have to review it, make sure it's good, bring it to the code quality of the rest of the project, bring it in, answering questions on the mailing list. How do I use this? Or even better, a question like, how do I add this? How do I add this feature? How do I engage with the project? Answering those kinds of questions, ensuring that the code quality is high just over the whole code base. When we're talking 160 formats done by sometimes many, many different people, code quality is variable. Doing security work, one of the things about maintenance is like this constant context switch. As platforms change, as static code analysis comes in, they find new bugs, new security problems. Documentation, just making sure that people can understand how to use it and how to contribute to it. All that work, all the other work of the project is unpaid and done for free, basically as a loss leader. It's a way of demonstrating you are in fact the person to whom contracts should flow because you do all this other work. So the good news is that this model has worked for some value of the word work. It's been okay for some time, for a long time, 20 years. But the amount of effort this requires of the maintainer, balanced against the amount of income it in fact generates, is not great. I don't think there's any doubt that programmers of the quality of the people who've been maintaining goo-gle for the last 20 years can and do make a good deal of money for a good deal less effort in different jobs in the private sector. So having a maintainer model that is based on the goodwill and the love of the game of particular individuals is not the most risk-free model for the organizations and entities that depend on the reliability and quality of goo-gle over the long term. So yeah, the first maintainer eventually got tired of it and burnt out and left to a newer, better paying job. If we lose the second maintainer, there probably won't be an obvious immediate replacement. If you look at the use of goo-gle, it's clear that most of the value is captured by the users and by big institutional users, right? They get a huge value in having this zero-cost tool that handles this really hard problem. But the only people who pay for the maintenance so far in the current model is this narrow band of governments and companies who pay for new formats and new things. So this model, this maintainer model, it's clearly not long-term sustainable. So the goo-gle maintainer model is changing. If you go to goo-gle.org/sponsors, you will see that many, but not all, of the cloud providers have now committed to multi-year maintainer sponsorship dollars. And those dollars are going to be managed by the goo-gle Project Steering Committee, which consists of current and past maintainers and major contributors to the project over the years, to grow the number of maintainers, make sure they're paid for the time that they spend on maintenance activities, and so that we can get these maintenance duties and separate them from the adding of features, the adding of new stuff, and make sure that they're given the same priority, that they're not the redheaded stepchild of the project, that they are given the same priority as new feature development. And then also be able to use this extra time to incubate new developers and new people who can come into that maintainer role. And the goal being to have people doing this core work in the plural, not one, not two, but 3, 4, a half dozen. The project will be stronger over the long term if we do that, which means the people, the organizations, these huge entities that are getting the value will be insulated from the existential risk of having the project go unmaintained.
Wow. Okay. So I feel like there's two stories here. We've got the first story of the Geospatial Data Abstraction Library, which is this amazing tool, free open source piece of infrastructure that anyone can use. And if you haven't already tried it, I suggest you go along to GDAL.org, download the package and start playing around with it, or at least look through some of the documentation and see what problems you can solve with it, because it really is amazing. It's baked into all these different kinds of software. We talked about user interfaces before and quickly came to realize that it's in the back of QGIS, GeoServer, and a whole bunch of other pieces of software. We have different programming languages that connect to it, and can use the functionality of this library. And then I feel like we've got this other story here of the business model of open source, perhaps, and the story of a piece of critical infrastructure which is perhaps in terms of the business model side of things has been neglected over the years. And perhaps even a realization that that business model needs to change. Maybe for the rest of the conversation, we can talk about a little bit about the business model of open source. I realize you've covered a lot of points now, but I'm wondering if we could just dive into that a little bit more. Could we consider this current maintainer model as almost like a freemium business model?
No, you can't really, because there's no gate on access to some other functionality. Freemium is another word for shareware in some respects. Those were old models of using a free price point to get people to try the software, which would then hopefully incent them to pay for the full featured version. But goo-gle comes in the full featured version, and it's also set up so that as folks get more involved in it, they can in fact contribute to it and put their oar in a way that, freemium software as a service models or old-fashioned shareware weren't and aren't. Those are really about corporate entities using free as a distribution model, not providing free access to software and source as a collaboration model. Because that's the difference. It's the difference between open source software and what was formerly called, freeware, is that freeware was put out there to spread around and be used widely. Open source software is put out there to spread around and be worked on together. And it's the togetherness aspect which defines open source. So not freemium. The closest thing I've come to this model, and it's the one you've laid out, is critical infrastructure. It's this idea that software becomes widely used, and the funding model has to recognize that it's the roads upon which everyone drives, and the people who are getting the value out of those roads need to up some money for it. We haven't gotten so far as being able to levy an open source tax that everyone has to pay. It's still very much a matter of enlightened self-interest. But there is self-interest involved. It's just bringing the enlightenment to the people who have the self-interest and letting them know about it so that they can exercise their self-interest muscles and give some money to these projects they depend on so highly.
I wonder if we could use the idea of the tragedy of the commons to describe the situation. Now, I realize this is a slightly different setting. I don't think often people talk about the tragedy of the commons in terms of software, but it feels a lot like we've got this common resource, this shared resource that we all have equal access to, regardless of where we come from or what we're planning on doing with it. We understand that it would be better for us if we invested in it and kept maintaining it, but for some reason that's been neglected. If we think of it like that, then we can draw a few parallels to the tragedy of the commons. Do you have any good sort of solutions for this? We've recognized it's critical. We've recognized that a lot of people benefit from this. What's the solution?
So the solution is to make sure that the people who have self-interest in this project continuing to go are in fact enlightened about the fact that they use it.
What do you think the disconnect is there? Because
the disconnect? Oh, it's just a disconnect between the people who control the budgets and the people who control the computers. So I mean, if you're a goo-gle user and you want to help the project, like the number one thing you can do is tell your boss that you use it and do that frequently. It's like, oh wow, I solved this problem by setting up goo-gle. Oh, that script that does the magic, that's actually running goo-gle under the covers. There are lots of people who use goo-gle and therefore understand how important and useful it is and the value of it, and the value of keeping it maintained and useful. But the Venn diagram of those people and the people who control budgets, those circles don't overlap very much. So it really is contingent on the people who recognize the value to communicate that value to the budget holding decision makers. Like the people who hold that budget, they know that there is value in the Esri software that's being used in their organization. And they know it because they get sent an invoice every year and they have to pay it. They go, oh, wow, this must be worth $50,000 a year because I'm constantly sending this invoice. And if I stop paying it, I know that the GIS techs are going to come up and say, but we need the software. But that loop of being told they need it and then having the dollar value assigned and then having to cut the check is missing in the open source software realm. And if the users do not communicate to the budget allocators that they're getting value. The budget allocators very reasonably will have no idea, and bad things will happen. So it's 100% a communication problem. If you're getting value from goo-gle, you gotta let the people who pay the bills know that you're getting that value, and let them know how they can help, how they can do the equivalent of paying their Esri maintenance contract. So yeah, if your use is large enough, tell the boss in your company that they should sponsor. Like, do not be silent. Go to goo-gle.org/sponsors. There are different sponsorship levels. It's not everyone has to sponsor. Not everyone should sponsor. Not everyone derives thousands of dollars in annual value from goo-gle, but many organizations do. As small as cities or states. And they should probably think about making sure that the tools they use are supported in the long term so that they're there in the future.
So I'm going to change tack just a little bit here to help sort of describe this next thought of mine. Online course creators, they discover overwhelmingly that if they give things away for free, the completion rate is microscopic. But as soon as they charge, and it doesn't seem to matter how much, but as soon as they charge anything for their online course, for their online product, the completion rate increases massively. Well, it goes from nothing to lots and lots and lots. And I think this can be summarized by the idea of, if you pay attention. And that's what I heard you say when you were talking about Esri licenses, for example. People pay for those and they pay attention to it. And so I wonder if we haven't done ourselves a disservice in open source world where we haven't sort of asked people to pay attention, to pay.
Yes and no. I mean, it is 100% absolutely true. But there are two aspects of open source which are just not consistent with that, and so we have to find other ways. Like, if you have to pay, then one thing that those courses will have noticed is that if you put the dollar cost above zero, the amount of people coming in the door drops dramatically. Open source has achieved ubiquity by virtue of being both free from a monetary perspective and free from the intellectual property perspective to use and reuse and rework. And you can't get a little bit pregnant, and you can't get a little bit proprietary. Once you put up those doors, you take away the things that give open source its superpowers. So I wish there was something to take away from that. I don't think that there is. I think we have to forge a new path.
So we get back to the idea of creating this attention around it. And you mentioned before that if you're a user of the software, please go and tell whoever's paying the bills that, hey, I'm using the software. It'd be worth protecting it. It'll be worth maintaining.
Tell your boss tell your boss, yes, if you are using it in a cloud environment, and if you're using a lot in a cloud environment, tell your sales rep also. There are a lot of hot CPUs out there in the cloud world that people are paying good money for, and the software that is making the CPUs hot and generating revenue for the cloud companies is goo-gle. But the cloud companies don't necessarily know that. They just see you using their compute and say, good news for us. But they don't recognize that they're being paid because goo-gle exists.
What's one sort of common misunderstanding do you think there is around this piece of software, around goo-gle?
I think the number one misunderstanding is one just related to scope and scale, because everyone approaches goo-gle from their own particular needs, and those needs can be quite narrow compared to the range of use. I'm a blogger. I've written several hundred blog posts. The number one blog post on my site year over year is always GeoTiff compression for dummies, which is just a step through of about 5 different compression options you can use on aerial or satellite imagery when writing out GeoTiff files using goo-gle. That's it. And it's the thing that people consistently come back to over and over and over again. And it'd be very easy for folks to think about goo-gle solely from the frame of, it's a format translation library, full stop. Because it's not. It's an access library, so you can build apps that don't care what the formats are, but nonetheless access them. It's got an incredible set of features around things like network access these days. So your imagery doesn't have to be local to the machine you're processing on. It can be off in the cloud. It can be in some Bitbucket. It doesn't have to be on a file system. That's a quantum leap in functionality compared to just 5 years ago. But people don't know that exists or even how to use it. So I guess it's the iceberg thing. Like, people are always looking at their tip of the goo-gle iceberg, but there is a huge hunk of stuff under the water that most people don't know exists.
Paul, thank you very much for your time. I really appreciate you patiently and slowly walking me through what GDAL is, what it isn't, how it's been used, and of course, the business case behind it and how we can support this piece of critical infrastructure. Thank you very much for that. Where can we go if we want to learn more about this, if we want to reach out to you personally, or if we want to connect in other ways?
So definitely go to goo-gle.org, GDAL.org, to get your copy of goo-gle and to learn about the project, /sponsors if you think your organization is interested in being a sponsor, or just to see some of the great organizations who have recognized that goo-gle is important to their workflows. If you want to read my blogs, including the GeoTiff compression for Dummies, I'm at cleverelephant.ca, and all my other contact information is linked to there.
Thanks again. I'll put links to all those resources in the show notes so people can click through and learn more if they're interested. Cheers, Paul. Really appreciate your time.
Thanks, Daniel.
I really hope you enjoyed that interview with Paul Ramsey. Again, he's been on the show a couple of times before, and I will put links to those previous episodes in the show notes. I'll also include links to a lot of the resources that Paul mentioned. If you're doing any sort of spatial programming, you probably already understand the value of GDAL, but if you're a non-programmer, it's well worth checking out GDAL. It ships with a bunch of incredibly powerful command line tools which just work. You download them and yeah, they just work. There's nothing else to install, and I think it's well worth taking the time to just look through the documentation and understand what these tools can do for you, if nothing else. So I really feel like the story of GDAL is divided into two pieces. So we have the functionality side of it. What can it do? How can we get access to these different tools? Where can we use them? Where is it being used today? What can it do for me? What problems can it solve? That kind of thing. And then we have the story of a piece of critical geospatial infrastructure and the business model behind that. I think the functionality side of the conversation is much easier for us to understand and to grasp because we can hopefully immediately see how this could benefit us. But I think the story of GDAL as infrastructure and of the business model which ensures that infrastructure is maintained and there when we need it, I think that's a different kind of story. And I really hope that when you listen to this podcast episode that you didn't hear the story of a starving artist begging for recognition. I hope that you heard the story of a community working to develop and support a piece of critical geospatial infrastructure. I hope that you heard the story of the same community generously insisting that the work continue, that we continue to benefit from decades of software development. So once we understand that this is not a story about any one of us, but a story about all of us, I guess the question, at least for me, becomes, well, how do we help? So Paul gave some great suggestions, and one of them was to tell people. If you work for an organization that derives significant value from using these tools, tell them. Let them know that there's an opportunity to support the tool. Let them know there's an opportunity to support the community. Help them understand the value of these software products. And maybe you need to tell them a story. Maybe you tell them a story of this is the right thing to do. Perhaps it's a story about the cheapest insurance policy they will ever buy. Maybe it's a story about cost benefit, that you pay more than nothing, but you get significantly more than what you paid for. And what happens if we don't work for such an organization? If we cannot influence their purchasing decisions, their spending habits? Perhaps the next best thing we can do is celebrate the people that have decided to contribute. So if I go to gdal.org/sponsors, I can say thank you to Maxar, thank you to Microsoft, Planet, Google, Esri, thank you Safe Software, thank you Coordinates with a K, Spark Geo and MapGears. Thank you very much for contributing. Thank you for giving back. Thank you for making things better for all of us. And that's it for me. That's it for another episode of the Mapscaping podcast. As always, it's an absolute pleasure being your host. Thank you so much for the people that take the time to reach out to me on social media, to send me emails. I really appreciate your feedback, and it really helps me shape the direction of this show. It helps me understand what you like, what you don't like, what you'd like to see more of, and yeah, and it just doesn't feel like I'm yelling into the void. So I really appreciate that. Okay, see you next week. Bye.